The tropical hot city of Lagos is the largest city in Nigeria and sub-Saharan Africa. The city with its 14 million people is one of the fastest growing cities in the world and one of the most populous urban areas. Lagos is becoming a major financial sector in Africa and has one of the busiest seaports in the continent. It initially emerged as a port city that originated on a collection of islands. Cities in Africa are predicted to see a high increase in their populations in the next few years, with Lagos on the forefront to hit record numbers. Nigeria's population is projected to double by 2050. Other predictions suggest that this African city could be the most populated in the world by the end of the century. Lagos' projected population by 2100 ranges from 61 million to an astounding 100 million. Lagos is a massive attraction for migrants, with a population representing a heterogeneous mix of more than 250 ethnic groups from different parts of the country, which makes Lagos a dynamic melting point. With its fast development and its diversity, it's becoming a blend of social and creative entrepreneurism, which triggered a surge in cultural consumption and increased investments. With the rapid urbanization increase, there is a high demand for housing and commercial spaces near the financial district in the Marina area. The brief. The project brief should deliver and answer the question: how do we safeguard and deliver high levels of environmental quality in the context of increasing intensification of land use? The brief also states that a target of 800 people per hectare shall be met in the design process. The tailored project has therefore been taken forward by displaying how we can manipulate the microclimate to maintain positive thermal comfort levels in Lagos to encourage pedestrians to use the space. The aim of this design is to provide high levels on environmental quality and comfortable environments for pedestrians and cyclists in Lagos through sustainable approaches to diminish the amount of carbon footprints in the area by manipulating the warm climate. One of Lagos's main problems is its massive traffic situation, with a lot of people using cars to move from one place to another. The warm climate in the area doesn't enable people to walk or cycle outside. People in Lagos tend to not work and live in the same place, and that has a massive environmental repercussion. Creating places where people can work and live at the same time, with all the different amenities only a few minutes away with good thermal comfort levels, would definitely encourage people to walk, cycle, or transit within the area. This project will demonstrate how mixed living in a highly intense urban area with a controlled microclimate is feasible. To be able to achieve this, one should have a comfort level target that shall be achieved in specific areas with specific design actions that shall be listed throughout the video. The site. A seafront site has been selected next to the Lagos Island Marina stop. The Nigerian federal government has gone into a private-public partnership on what is called the Marina Quayside project. It hopes to replace 45 hectares of car parks with a transformative urban and waterfront development project intended to be a tourist center that will provide hotels, condominiums, commercial complexes, amongst many other facilities in the city. The plan was to create a vibrant and beautiful waterfront development accessible to all. This will be achieved through the remodeling of the waterfront site to create a global strip that will absorb existing intensification processes while also encouraging interaction between different socioeconomic groups. The initial group master plan didn't fully achieve its microclimatic control goals and had a lot of problems. There were many initial challenges in the site, including the elevated motorway and train rail, which we had to design around and implement in our design project due to the expensive socioeconomic costs of removing it or implementing it underground. For the refined brief, the solutions found in my specialization topic of controlling and maintaining good thermal comfort levels will at the same time resolve all of the above qualities. The chosen site is the Marina area, which is the commercial capital of Lagos. The waterfront is a valuable piece of land which will be developed for commercial and housing purposes, creating employment and revenue for the area. It has also been selected due to its central location, proximity to the marina port, and its transportation proximity. The selected blocks didn't fully deliver these environmental qualities with its massive green public space next to the marina, which wasn't functional and wasn't put into use. Design process. Main goal of the thermal comfort levels is to encourage pedestrians and cyclists to use this space and diminish the overall CO2 consumptions by controlling microclimates in the area. This is all linked to design processes such as climate control, accessibility, legibility, variety, mixed use, safety, environmental sustainability, and community. The development incorporates a mix of uses and amenities to reduce the needs of cars. The development has an urban compact form with mid to high density ranging from 3 to 19 stories, increasing energy efficiency and reducing the required infrastructure per person. Climate control. Many studies on thermal conditions in warm, humid cities like Lagos have been made in previous years. It showed how the thermal conditions are stressful for the public and that the elevated temperatures lead to more heat stress, which results in an increase of energy use, such as air conditioning and CO2 fossil fuel emissions from cars. Many public realm environments, especially the ones in warm cities such as Lagos, are poorly designed, regulated, and not thermally comfortable. The temperature in Lagos can rise as high as 33 degrees, with an overall estimated average of 30.6 degrees Celsius. The minimum lowest average is around 22.6 degrees Celsius. Studies in warm countries with similar climate as Lagos examined OTC according to neutral, acceptable, and preferred temperatures. Where people felt comfortable outdoors in the park, the study estimated that neutral temperature, when all respondents experienced neither heat nor cold stress, is 26.2 degrees Celsius. Acceptable temperatures, when only slight heat or cold stress is experienced, range between 21.6 degrees and 31.6 degrees Celsius, and the preferred ideal temperature for all respondents is 24.2 degrees Celsius. Therefore, the goal is to diminish the average 31 degrees Celsius number to a comfortable level for pedestrians. Using vegetation and trees. Field data shows that vegetation reduces the local temperature of the surrounding air and surfaces, which is caused by evapotranspiration, low heat capacity, and the reduction of solar radiation. Vegetation extends this cooling effect during the nighttime when cool night winds and a clear sky is present. Trees prevent solar radiation reaching pedestrians. Shading from the tree canopy makes trees the most effective and efficient vegetation approach for cooling. A tree's canopy acts like a parasol, blocking out up to 90% of the sun's radiation, and increasing the amount of heat that we lose to our surroundings by cooling the ground beneath us. The shade provided by trees can reduce our physiologically equivalent temperature by a minimum of 7 degrees Celsius, and sometimes even higher, as much as 15 degrees Celsius, depending on our latitude. This can reduce the overall average temperature for the users from 31 to 24 degrees Celsius, which is an ideal temperature for all the respondents. The trees shall be planted throughout all the public pathways on the master plan. Green roofs and green open spaces. Green open spaces and green roofs will not provide shade for pedestrians unless trees are included. Green walls and facades can provide shade if grown over artificial structures. Large green space help maintain and reduce urban heat island effect and reduce artificial cooling. The tallest buildings will also include green roofs and walls to control the internal and external temperature. Types of trees planted. The types of vegetation on the screen have been chosen to be used around the site for their thermal comfort characteristics. Deciduous vegetation will be planted in the south of the site to protect and create shade during the warm periods and at the same time allow sun to slightly enter the building when the temperatures are lower. Trees such as the common hop tree, mangrove, and Thymus vulgaris have also been implemented. Courtyards. Main shared public courtyards with vegetation have also been used to help reduce the overall main urban heat island effect within the perimeter blocks. Wind. The street blocks have been designed in order to trap the southwest prevailing winds inside the perimeter blocks within the courtyards. The building design also enables natural ventilation throughout all the dwellings. Blue network. Blue networks in urban environments have the capacity to have less daily annual temperature changes. This stabilizes and restrains the thermal circumstances in areas that are in proximity to the sea, where the shore breezes substitute the hot air over the land and cools down the land that has been heated up by the solar radiation during daylight. This has been implemented by having a fisherman canal blue network within the development, which connects the marina to the neighboring islands and at the same time creating beautiful views for the residential and commercial leisure facilities. Street width. Target wide open streets with a low building heights to streets width ratio to provide shade. Wide open streets are exposed to greater amounts of solar radiation, leading to higher daytime heat stress. Street orientation. The target is the east-west oriented streets. East-west oriented streets are exposed to more solar radiation during the day compared to north-south oriented streets, where some building shading occurs in the morning and the afternoon. The solar canopies. Solar canopies have been implemented where necessary, such as in the low-rise single-family and commercial units, where solar panels will harvest more energy and provide shade to the users. It has also been used in the vertical garden in residential buildings as a pergola to capture the sunlight and provide shade within the vertical gardens. Materiality. The use of light-colored materials and other design techniques to reduce the overall urban heat island effect internally and externally by using an urban albedo approach. The map displays all the different approaches that have been used on site, such as reflective roofs, natural green materials, blinds, insulation, low SHGC coefficient for glazing, and light-colored street pavements that have been used. Building heights. Taller buildings have been placed in the north to minimize overshadowing near the ocean front and at the same time to not block the ocean views from the other buildings on site. The tallest buildings were also placed on the high street facing the elevated bridge, as that is the widest street on the site and needs the most shadowing. Urban breaks of 4 meters and 1 story also allow for wind ventilation throughout the buildings. Streetscape Framework Study. A chart framework developed by Norton. Their research on planning for cooler cities also classified streets into varying levels of priority for street tree implementation. This table was developed with the aim of reducing street surface temperatures during the summer solstice in warm cities. I have changed the framework chart and adapted it to the layout street heights that exist in my development. The table identifies which streets should be prioritized for street trees based on the street orientation, example east, west, or north-south, the width of the street and the height of the buildings abutting the street. The ratio of building heights to street width is known as the height to width ratio. Those zones marked as red are of a higher priority for street tree planting, as they are exposed to high amounts of solar radiation and so tree shading is most needed. Those zones marked green and blue are less of a priority, as buildings along the street provide shade. The first street with the vertical high-rise residential gardens has a gradual increase in floor height as displayed on the map, so the need to know if trees are essential depend on the exact location within the street. The street is 20 meters wide with an increasing canyon height from 8 meters to 60 meters at the end of the street. In the beginning of the block, it scores a low 0.40 points with both an imperative need of trees on the east-west orientation. Only when reaching a 40-meter high canopy that it scores a green 2.0 points and doesn't need much trees. As for the north-south orientation, it scores a positive 1.0 starting from a 20-meter canopy height. The second street is also a medium-sized 20-meter road but with canopy heights on both sides. It scores a similar result with the similar building height that gradually increases. It does need trees in the beginning of the street, but it creates enough shade throughout the street with a green 1.0 and the other office residential building scoring a positive green 1.6 points, which makes the street a very well shaded street with good thermal comfort levels. The third street has a 17-meter width with a much lower height canopy in the beginning of the street. The office residential building has a 16-meter height scoring an average yellow 0.9 score, which still needs some trees. Then afterwards, the height changes to 36 meters, which projects enough shade to the whole street and has a positive blue score of 2.1. The low-density, low-rise block scores a perfect score with their solar panel canopies that provide shade to the whole block and doesn't need any vegetation. As for inside the perimeter blocks, the pathways all use vegetation and trees to provide shade for the users and encourage them to move from one place to another. The map shows the street hierarchy and has been designed to enable a good level of permeability while at the same time reduce the number of cars used within the blocks. Eco-friendly permeability has been implemented to minimize the use of cars within the development. The main Marina Road with the High Line Bridge is the busiest, and that is why medium streets have been designed throughout the Marina streets to limit and filter the amount of cars that enter and have access to the oceanfront street. On the other hand, access within the blocks is only possible by walking and cycling. Different parking access points have been placed within different areas of the blocks and buildings with massive two-floor underground parkings underneath each block, which is used for the residents and services for the different commercial shops. The map also shows the courtyard access, retail entrance, other commercial entrances, parking access for residents, the underground servicing network, single-family entrances, and the multi-dwelling entrances. Creating a landmark through the marina and the vertical garden residences have also been designed as landmarks and as the central core of the development, which are visible from afar and creates a sense of legibility and identity to the area. Side transport connection. The area has also been designed to maximize the public and all social groups to access the site and use the different commercial and leisure shops by designing the development close to the marina station and designing a ferry point that connects to the different lagoons and islands. This will increase the amount of people that access the site and use the amenities as well as the number of commuters that will be arriving without the use of a car. Building heights. Varying roof heights creates character and identity unique to the city. Lagos's financial district, which is linked to the site, ranges in high and low-rise buildings, creating a varied skyline that matches the marina development. Apartments, studio, and duplexes with hanging gardens and single-family houses are mixed around the site to create a variety of dwellings. There are different block characteristics such as the vertical garden residential building, which is the densest part of the development and proposes elevated private gardens for the users within their blocks. The second block, which uses perforated solar panels to diminish the amount of sun that goes through the glazing, is more compact with mid-size heights and incorporates office spaces and commercial units in the ground floor. The third block includes the 3-story single house units for bigger families and for a more souk market feel in the ground floor where people can interact, do business, and socialize in the market. The plots have a fine-grained feel with different layouts, materiality, and character, which creates a sense of change and variety. The overall vision of the area with its different typologies and characteristics create variety, diversity, and dense urban living while ensuring activated sheltered spaces for pedestrians. Mixed use. Creating a spatial flow from public to less public spaces by implementing shops, cafes, restaurants, and other mixed-use amenities. The people in Nigeria like to have their own private space, and that is why there is no residential units on the ground floor and why there are commercial shops in the ground level connected to the underground parking for services. Creating a live-work environment by creating office spaces in the second middle block exist within the second and fourth floors to encourage people to work within the development and at the same time attract more commuters who can use the commercial shops in the ground levels. Safety. Promoting a sense of safety is of a paramount importance as it encourages people to go outside and is an essential element in urban design. All streets have active edges, as do most courtyards, to provide active surveillance. Active frontages, fronts to fronts, backs to backs, this increases natural surveillance and positive streetscape characteristics. Introducing shaded terraces and balconies throughout the block structure with big windows with perforated louvers enabling the user to diminish the temperature and direct sun effect, but at the same time enables the residents to look outside the streets. Environmental sustainability. Design actions in this one includes recycling trash areas drops in every building in the underground servicing network, recycled water that can be used in irrigating the green vertical gardens, solar panels that can provide more solar energy to the overall blocks. They have been placed on top of every building and every balcony or terrace pergolas. The use of trees as vegetation barriers from the main high streets and the High Line Bridge to reduce the noise pollution from the area. Passive cooling systems such as cross ventilation and louvers enabling the flow of wind throughout the blocks to reduce the need of ventilation. Community. Creating a welcoming public realm for all societal groups. All public spaces should have a human scale The blocks are on the average around 65 by 120 to still enable a human scale experience with an inclusive environment and sustain their residential demand in the area to achieve 800 people per hectare and to create new businesses and office spaces. It has been designed for connectivity and to encourage walkability. Having social cohesion for all religions and tribes is of paramount importance. Creating spaces for different purposes available to use for all ages and social cohesion for all religions and tribes. That's why cafes and restaurants have been placed in front of the waterfront blue network for people to use. Introduce areas for public activities, example interactive art, street performers. The different blocks also connect to the cultural green promenade that was designed on the other side. Street furniture strategically placed and designed to encourage communication. Benches should be placed to face pedestrian flow. Encouraging the fishermen culture in the area and enabling them to sell their stocks in the marina markets. Embracing the powerful market culture in Lagos by creating a souk-like block with narrow streets with shops on every active front in the ground level. Children's play area away from city traffic, close to the marina park. Sports under the bridge activities for older, more responsible people, proposing many sports in a secure, shaded environment for everyone to use. In general, the intensified area has a resident population density of 800 people per hectare, 80,000 square meters residential, 15,700 square meters commercial spaces, and 11,000 square meters of office spaces. This fits with the master plan requirements. The master plan development is highly inclusive, proposing distinctive sustainable blocks that encourage people to walk throughout the site. It does an excellent job in analyzing the different thermal comfort levels throughout the main streets within the site to have an idea on how to improve the thermal comfort levels in the future. It shows the different natural and sustainable design solutions that are appropriate to the Lagos site. The development also proposes some variety in dwellings and other facilities while respecting the basic urban design qualities. The overall project shows the effects of intensification on the area while keeping a degree of inclusivity and having a degree of social cohesion for all the different groups, while at the same time have a sustainable approach to controlling the microclimate in the area. It is clear that a lot of data regarding the preferred thermal comfort figures for each city's warm climate needs to be more accurate to have more precise data. The lack of precise data and information about Lagos is lacking online, which makes people look for similar countries with similar profiles which are then applied to the site. Maybe in the future, more designers and urban planners will have access to these precise numbers about the area, which would definitely enhance the framework study. Another thing that I wish the development could include is more unique plot designs other than the perimeter blocks, and maybe could implement more diverse typologies in its blocks. To conclude, future planners and designers should take into consideration these microclimate solutions in warm cities to reduce the overall CO2 emissions. African cities are growing at a very fast pace and need to adapt and transition towards more sustainable developments for a better future.